Hey everybody! It's a new year! Happy New Year! It's 2014 and well, I've not a wee video in a while. I'm sure you've been missing me as much as I've been missing you. So we're back today with a new higher topic. We're here with trigonometry. Yay! I don't know if you can see my arms. No, you can't. Oh well. Yeah, we're here with trigonometry. One of the things you hear an awful lot about, and people say it's scary, but it's actually pretty straightforward. It's only when you start learning stuff on top of the trigonometry that's quite makes it quite tricky. So we'll make a start, will we? Let's see how we get on. Right, starting out in trigonometry. Before really exploring what trig is all about, it is important to point that the work we do applies only to right angle triangles. So much like Pythagoras' theorem before it, this only works with right angle triangles. We will use the trig functions with other types of triangles, but the general rules of what we do today only apply to right angle triangles, and as such, you should treat it like that. Okay, like that. That's what a right angle triangle looks like. I forgot to put the right angle in. I'm such a dunce. Oh well. Next thing to do is check that your calculator is set up properly. We're starting to get into the realm, or you will start to get in the realm when you get to GCSE, that an awful lot of those other buttons that are on the calculator start to come into play, whereas you might only use the numbers 1 to 9 and the basic functions and maybe a square root button and a square button beforehand. But we're going to start to use the other things. So you might have messed up the settings before on your calculator, going into mode or setup or whatever the things on your calculator are, and it wouldn't have affected your answers until now. Okay, so what I want you to do is press the following buttons. I want you to press the coast button, or find the coast button on your calculator. I want you to then press the 6. I want you to press the 0. And I want you to press equals. Now, all being well, you will get 0.5. Did you? Good. If you didn't, you messed up a sentence, and you should be able to check. If your calculator set up wrong, you'll be able to change it 2 degrees. And it's sometimes indicated by along the top, there'll be a bit that says DEG in capital letters. If yours says RAD, it's set wrong, and you should be able to go into setup and mode and set it DEG. I think it's one of the first options in the Casio ones anyway. If you're really having trouble with it, or you really can't get sorted out, bring it into class on Tuesday and I'll sort it out for you. We'll have a look. We'll solve that mystery ourselves. Put on my Columbo hat and coat and stuff, and we'll be sorted. Alright. So the right angle triangle. Basis of getting an awful lot of these things correct, both in Pythagoras theorem and in trig, is to label it correctly. So we have a right angle triangle that looks like this, and this time I put in the right angle. See the way I did that time? It's right there. I'm so proud of myself. So the right angle's down there. So the first thing to do, there are 3 types of side, and we'll discuss this last year. The longest side in the right angle triangle is the one opposite the right angle, and opposite means it's over here. This is the one opposite the right angle triangle, and it is called the hypotenuse. It's not called the hypotenuse or the hypotenuse. It's the hypotenuse. I know it's a funny word for what is essentially the longest side of a triangle, but I kind of like it. There's not another word that I can think really like it. It's the hypotenuse, and it's quite cool. So it's the one opposite the right angle. Now, the other 2 depend on where the angle you're trying to work out in trigonometry is. So trigonometry is all about angles and using the angle within a right angle triangle to solve and find out measurements in the rest of the triangle, whether that be another angle or whether it be a length of one of the sides, etc. So if I put the angle over here in the wee Greek letter, which we'll come back to in a second, then the side that is opposite that angle is called, not believe it, it's actually called the opposite. For I don't know who thought of the idea to do it, but yeah, the one opposite the angle is called the opposite, and the one that's beside it isn't called the beside. I know what you were thinking. It's called the adjacent, though. It's a fancy word for beside. See that? So the opposite is across from the angle you're talking about, and the other side that's left, if you really want to think of it that way, is the adjacent. But it's kind of the side touching the angle, so it's adjacent to it. However, if the angle was up there, it took me 20 minutes to do. I'm only kidding. 8 or 9. Then the opposite just changed, because the side that's opposite the angle now is this one. And it's the opposite, and the one that's beside it or the adjacent is over here, and that's adjacent. So when you set up any of these problems, they might twist the triangle around or whatever, you can label the hypotenuse, the opposite, and the adjacent, and that's one of the first things you should do, because we use the Greek letter theta to represent angles we don't know much, in the same way that we used x to denote an unknown number or an unknown length or side or something like that previously. So in right angle triangles, we use x to find still to represent unknown sides. We use the Greek letter theta to do that. And what else did we use? Sigma last year for working at the mean, isn't that right? Building up our knowledge of Greek letters. In fact, if you ever go to a pub quiz and they go write down as many Greek letters as you can, you're a couple ahead of it, most of the rest of the teams with non-mathematicians in it. You know, most people get alpha, beta, omega, gamma maybe. You can stick sigma, you can stick theta in. No, we don't do epsilon this year. Damn it. But there's another one for you. Extra bonus points there. You're right in there. It's great. Pi's another one. You know that one. So, other new scary words. Sine, cosine, tan. Or sine, cosine, and tangent. That doesn't know the mothers, because we all know mothers all call us by our full names. I get Christopher. The only person who calls me Christopher. And if tan gets called tangent, he probably thinks he's done something wrong. The names given to the three different ratios you can get from a right angle triangle. Okay, so ratio is just when you divide one number against the other one. So it works something like this. Sine is the ratio between the opposite and hypotenuse, which kind of gives us the formula sine of the angle, sine of theta, equals the opposite divided by the hypotenuse. Cosine is the ratio between the adjacent and the hypotenuse, and again, it gives birth to this formula. Cosine of theta equals adjacent divided by hypotenuse. And tangent is the ratio between the opposite and the adjacent. Tan theta is opposite divided by adjacent. And the order in which you put those, the hypotenuse always goes in the bottom, and then the other ones alternate on top depending on what you go. So remembering these is quite important. So how in the world, like, it's hard enough to remember area equals length times breadth. It's hard enough to remember that the range is the biggest number, take away the smallest number in a data set. So how are we going to remember it? SOHCAHTOA. This can present some problems, especially people from Belfast, because we tend to say it SOHCAHTOA, mate. SOHCAHTOA, which sounds like SAHCAHTOA. So we say SOHCAHTOA, right? It'll keep you right. It's a helpful acronym to help us in trig. So each of the letters works in the following way. S is for sine, O is for opposite, H is hypotenuse. C is for cosine, A is for adjacent, H is hypotenuse. T is for tan, O is for opposite, and A is for adjacent. And if you notice, this is the list of the trig functions and the ratios they refer to. So sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tan is opposite divided by adjacent. These are your ratios for each other. So if you can remember SOHCAHTOA, you're well in. I told you, easy. So the process for solving trig problems, and I keep on shortening trigonometry down to trig because it's just much shorter. First step is to label each side properly. We've just shown you how to do that before. Second bit, we're going to pick the appropriate trig function by looking at what we want to work out and what you know. Okay, and you'll see this when we go through the couple examples that we have. We will work out what we know and what we want to know, and then we'll use the appropriate trig function. And then step 3 is calculator at the ready. It's like a weapon. A calculator is your weapon for trigonometry. Should have put in a picture of a gun or something, or a big club with nails coming out of it. Something like that. So let's look at an example. We have a right angle triangle like this, and we have to find x. I'll look at a quick overview of the triangle. We've got our angle down here, we know this side, and we want to find the length of this side up here. So first thing to do first is label the triangle the same way that we did beforehand. So the first thing to look at, the longest side of a right angle triangle is this one. It's the one opposite the right angle, if you're ever confused or if ever it looks funny. So we call that the hypotenuse. We have our angle here, so this bio over here, what do we call this side? That's right, it's the opposite. And the other one that touches the angle, or has on a side touching the angle, is called the adjacent. And we're off and running. Next part to do, we're going to pick the correct trig function. What side do we know? Well, we know the length of the adjacent here is 10 centimeters. What side do we want to know? Well, the x is on the opposite. And we ask ourselves the question, which ratio has adjacent and opposite as the sides? So if we do the SOHCAHTOA, we'll get 10. I pretended I didn't know what that was there. See? You'll find this hard to believe, though. I was always terrible at acting in school. In fact, we did a Shakespeare play once in school. I was the only person who auditioned for the part, and they cut the main part of the play down to about 4 lines because it was that bad. What can you do? We all have our different skills. So tan theta is equal to the opposite over adjacent from our SOHCAHTOA. So we'll plug in the values that we know. We know tan theta, in this case, is 55, equal to the opposite, which is x, and the adjacent, which is 10. And we're going to rearrange this equation. We're going to get x just on its own, so we're going to have to move the divided by 10 over to the other side. When it moves over to the other side, it does the opposite of what it was doing. The opposite of dividing by 10 is multiplied by 10. Now, you would have 10 times tan 55 equals x. Hint, when putting these into your calculator, do the tan of your angle or the sine or the cos of your angle first, in this case, and then multiply it by 10. So what I've done is I have decided to put in the buttons you should press and the order you should press them. So press tan 55 multiplied by 10 equals. You shouldn't have to hit equals after the tan 55, it should just come up with a number. There might be an old calculator or something that needs to do that, but if that's happening to you or you don't get an answer from tan 55, it doesn't change. We'll have a look at that in Tuesday, but most calculators that I've ever, or every calculator I've ever seen, once you hit tan 55, you're sorted. In some cases, like an iPhone calculator, if you're using it, you have to do 55 tan and then times 10. Okay, if you hit tan and then 55, it'll just come up 55 on an iPhone calculator. It needs the number first and then tan, so you might need to switch those two around. But either way, you should get 14.3, and that would be centimeters, and that's the 1 decimal place. Hopefully you got that, and hopefully I got it right, because I was using an iPhone calculator to do it, but we shall see. Alright, example 2. This diagram is not to scale, and you'll see why. We have our angle moved up here, and that is not a 13-degree angle, but the general idea stays the same. We have to find x. So the first thing we're going to do is we're going to label the triangle. We've got our degrees here. So the longest side of the triangle is the one that's opposite the right angle, and it's this one here. That's the hypotenuse. Okay. The one touching the one on the left here is the adjacent, and the opposite is the one facing the angle there, so it's labelled correctly. Second bit is we are going to pick the correct trig function. So what side do we know? We know the adjacent. What side do we want to know, or do we need, is the hypotenuse. Which ratio has adjacent and the hypotenuse as the sides? SOHCAHTOA. Not really going to act it anymore because it didn't work out so well the first time, but it is cosine. Or cos. Or cos. Depending on what way you call it. Where you're from and what part of the country you're from. So, we'll use cos of theta equals the adjacent divided by the hypotenuse. Okay, we'll throw in our sides. We know the angle, or the degrees, is 13, so if cos of theta equals 6 over x. Rearranging this equation, which is a bit harder because we need to get the x up there first, and then we'll have x times cos 13 and take the multiply by cos 13 and move it down. We will get x equals 6 divided by cos of 13. And in this case, you can't do the trig sum first because it's on the divided, you're dividing by it. So the numbers you would press would be 6 divided by cos 13 equals, and you should get 6.2 to 1 decimal place. Again, on an iPhone, you'll probably do 6 divided by 13 cos equals, and that'll give you 6.2. All being well. One more to do. What happens if we need to find the angle, like so? Our angle's down here, we've been given two sides. What do we do? Do the same steps. We still label the triangle. So the longest side is the one opposite the right angle. There's the hypotenuse there. Our opposite is the side opposite the angle. Is over there, which leaves us the adjacent down here. We've got to pick the correct trig function. What side do we know? Well, we know two sides. We know the opposite and the hypotenuse. What side do we need? None. We just need the angle. Which ratio has opposite and hypotenuse as the sides? Opposite and hypotenuse. Well, it's the one that we haven't done yet. It's sine. And we get sine of theta equals opposite over hypotenuse. So substituting the values is done like before, but looks a bit different. We still don't know the angle is equal to 8 over 10. And we can do 8 divided by 10 gives us 0.8. We don't need to rearrange this equation because it's already like that, but it's causing us a bit of problems. The way we used the calculator before won't work. So what we need to do, we need to use the inverse sine function. And I have spelt sine wrong. I can't believe what I was thinking it obviously in my head and typing the same. So it should be SINE, and I'll correct it for when I put the thing on the site. Which you should see above the sine button, and it looks like that, sine to the -1. Using your knowledge of indices there, if you remember any. 1 over sine, blah blah blah. Okay. So the way that works in the calculator is like this. You do second function, or it might be shift on your calculator. Sine gets the wee thing to be sine to -1, and you do 0.8 and equals, and you should get 53.13 to 2 decimal places. Please God I have it right, because I did it on an iPhone and it's a bit clunky. Don't like using the iPhone calculator, but it's what I had to hand when I was doing this, and that is trig, or it's basic trig, should I say anyway. It is a higher only topic, and those are the main questions. Now it does get combined with Pythagoras theorem and things like that, to make the questions a bit more complicated, but large, that's the basis of trig. You know, I've shown you the 3 different types of questions that you usually get, and that's them. So let's recap. Trigonometry is a way of using ratios in a right angle triangle to work out other measurements of the triangle. We use the acronym SOHCAHTOA, and we use the 3 steps, even though the third step is kind of using your weapon to solve the problems. Hope you followed today. Any questions, email me or bring them to class, would be even better. There are some examples in the notes there if you want to go through them that accompany this. Good luck, and I'll see you in class on Tuesday. Bye.